Greetings, learners. Hope you are doing well. In today's presentation, we're looking at how to find the domain of any function. In my previous video, I've explained the concept of mapping and function. To find the domain of any function, there are 5 cases. In today's lesson, we'll be looking at only 2. Let's look at the concept of domain. What do we mean by domain? Domain means all the possible values, x values you can have in a function. Domain means all the possible x values, you can have in a function. In other words, all the x value that is allowed in a function is called domain. Okay? For you to have a domain of a function, what are the possible value of x that will make that function to be defined? Okay, that's what we mean by domain. As I said, domain means all the possible x values you can have in a function. Okay, this is further mathematics. By the way, if you are coming across this channel for the first time, thank you for joining me. Please hit the notification button so that you'll be notified whenever I upload a new content. This is TJ's Maths and Further Maths Adventure. And don't forget to subscribe. Thank you. Domain means all the possible x values you can have in a function. As I said, we'll be looking at 2 cases out of the 5. The first one, when we have a polynomial only. When we have a polynomial only, let's say we have f of x equals to x squared plus 3. That's Roman numerals 1, a polynomial of degree 2. Let's say we have just a linear function, polynomial of degree 1 now. Let's say x plus 3. How can we state the domain of this? How do we state the domain of this? The domain of these 2 functions here, let's say this is f of x now. The domain of these 2 functions will be all real numbers, all real numbers. Or we can write it in parentheses like this, all real numbers. Or we can use interval notation as minus infinity to positive infinity. Okay? All real numbers. So the domain of this function, what do we mean by all real number? It means any other negative or positive number, if we plug it into this function, it will be defined. Let's say negative 1. Negative 1 square is 1. 1 plus 3, 4. We're having something. Okay? The function is defined. It's not undefined. The function is defined. Even if we plug 2, 2 square is 4. 4 plus 3, 7 is defined. The function will exist. But for you to have a situation whereby when you plug a number or any real number and the function is not defined, meaning you can't find the domain at that point. Okay? So this is the first case. When you have a polynomial of different degrees, it could be degree 2, degree 1, as the case may be, or 3 or 4. That is case 1. Let's look at case number 2. Fractions only. Let's say we have a function f of x as x plus minus 3 divided by x squared plus 5, x plus 6. To state the domain of this function, just set your denominator not equals to 0. You don't bother about the numerator. Just pick your denominator. It must not be equals to 0. In other words, x squared plus 5x plus 6x must not be equals to 0. Then solve for x. Okay, let's solve for x. This is a quadratic function. This will be x squared plus 3x plus 2x plus 6 must not be equals to 0. We can group this in this order. What is common here is x into x plus 3. What is common between 2x and 6 is 2 into x plus 3 must not be equals to 0. You realize that what we have in the bracket are the same. We can pick what we have outside the bracket, which is x plus 2 in one bracket, then we have x plus 3 in another bracket must not be equals to 0. Okay, we can solve for x here. Let's move here. It means x plus 2 is not equals to 0, or x plus 3 is not equals to 0. So let's solve for x. X now must not be equals to minus 2, or x must not be equals to minus 3. Why? Because if we plug minus 2 into this function, it will be undefined. You plug x in this denominator here, it will be 0, and division by 0 is not allowed, does not exist, or is not allowed. Okay, so the domain of this function will be all real number except minus 2 and minus 3. The domain of this function now will be all real numbers except x must not be equals to, except x not equals to minus 3 and x not equals to minus 2. So this will be the domain. We can use interval notation, or we can state it as like this: all real number, all such that x must not be equals to minus 2, comma x must not be equals to minus 3. We can state it this way, it's still correct, whichever way, or we can use interval notation. To use interval notation now, it will be, or we can say any negative number from infinity, but minus 2 is not included, combined with any negative number from infinity, but minus 3 is not included. We can use this interval notation. Whichever, whether this first one or this one or this one, they are the same, is correct. And any of these ones are correct. Any negative number from infinity, but minus 2 is not included, that's what this means. This bracket means is not included. Combined with any negative number from minus infinity, but minus 3 is not included as well. So this is how to state the domain when you have fraction only. Okay. Sometimes we may have another example. Let me give you another example under this. Let's say we have a function f of x as x, let's say plus 2 divided by x plus or minus 3. Let's say minus 3. Okay, this is a rational function. You may ask to state the domain of this function as well. It's the same thing. For to state the domain of that function, just pick what is in the denominator, which is x minus 3. X minus 3 must not be equals to 0. X now must not be equals to 3. So it means the domain to this function will be all real number except 3. All real number except 3. X cannot be equals to 3. X cannot be equals to 3. So we can write it as all real numbers except 3. All real number except 3. It means any numbers that we plug into this function, it will make the function to be defined except minus 3. Minus 3 is not included. Okay. We can use interval notation if we want. We can say minus infinity to 3. Minus infinity is not included, 3 is not included, combined with 3 is not included, to positive infinity is not included. What are we saying here? It means any negative number down to 3 is not included. Any negative number 3 is not included. 3 is not included here. Combined with is the same thing. It means any negative number we plug into this function will make the function to be defined, but not 3. The same thing here, whether positive numbers we plug into this function, it will make the function to be defined, but not 3. So we can either use this interval notation to state uh, this domain. So the domain is all real number except 3, or we can use this interval notation, or we can state it as all real numbers such x such that we can say x such that x belongs to the set of all real numbers, but x cannot be equals to 3. This is another way we can state our domain. X such that x belongs to the set of real numbers, but x cannot be equals to 3. Why? Because if we plug x as 3 here, 3 minus 3 is 0. It will make this function to be undefined. The function will not exist. So this is the solution to this question. As I said, in today's presentation, we're looking at only 2 cases. In my next video, we'll look at the other 3 cases that you may be asked to find the domain. Thank you for watching. Please do share this to your learned colleagues, and don't forget to subscribe to TJ Smarts and further maths adventures. Thank you.